To find the distance to nearby stars, the method of parallax is used. The idea is to find a triangle with the star at one vertex and with a base as large as possible. To do this, the star is observed at two different times exactly 6 months apart, and its apparent change in position is recorded. From these two observations, angle E1 SE2, let's see what that is, E1 SE2, this angle, can be calculated. The times are chosen so that angle E1 SE2 is as large as possible, which guarantees that angle E1 OS is 90 degrees. E1 OS. The angle E1 SO, E1 SO, E1 SO. The angle E1 SO is called the parallax of the star. Sirius, one of the stars nearest the Earth, has a parallax of 0.000106 degrees. I can understand how the parallax could be used if you were standing on the Earth somewhere and you wanted to figure out where that star was, and so the parallax is the angle measure that you have to look out. Estimate the distance to this star from E1. Take the distance from the Earth to the Sun to be 9.3 times 10 to the 7th miles. Enter your answer in scientific notation. Round the base to 2 decimal places. Okay, so here's the answer. Let's see how we get that answer. Essentially, we know the measure of this angle theta. We know that this is a right triangle. E1 OS is a right triangle. That means that we have a right angle here. The side that we're trying to determine is E1S, and that is the hypotenuse of the right triangle. So you just need a trig ratio that has hypotenuse in it. You could use opposite over hypotenuse, or you could use, well, I guess that's what you have to use, because you know how far the Earth is from the Sun, 9.3 times 10 to the 7th power million miles. So the distance from O to E1 is 9.3 times 10 to the 7th miles. That's how long this is. You know this length, and you know the angle theta. This is the side opposite theta. You want the hypotenuse. Use trigonometry to find this hypotenuse.